This video presents the menstrual cycle, which includes the ovarian and uterine cycles. The menstrual cycle is a process that normally takes around 28 days to complete. It involves a series of cyclical events coordinated by hormones that occur in both the ovaries and the uterus. The order of control is hypothalamus to the anterior pituitary gland, to the ovaries, to the uterus. The ovarian cycle is a crucial part of the menstrual cycle that involves the maturation and release of an egg from the ovary. The cycle has two phases, the follicular phase and the luteal phase. Let's start with the follicular phase. At the beginning of the cycle, several follicles in the ovary start to mature. These follicles contain immature eggs. As the cycle progresses, one dominant follicle continues to develop while the others disintegrate. This dominant follicle releases the egg during ovulation. The follicular phase varies from female to female. The luteal phase is more consistent. During this stage, it's post-ovulation, the ruptured follicle transforms into a structure called the corpus luteum. The corpus luteum produces progesterone, a hormone crucial for preparing the uterus for potential pregnancy. If fertilization does not occur, the corpus luteum breaks down, leading to the start of a new cycle. This slide provides more details about the follicular phase, to include that the congruent events occurring in the uterus is the discharge of menstrual fluids, and that roughly 25 primary oocytes that begin developing together, they transform and are housed in secondary follicles, and this is completed in day 5. The pre-ovulatory stage proceeds from days 6 to 14. During this time, only one follicle emerges as the dominant one. The others undergo atresia, which means that they degenerate. The dominant follicle will protrude from the surface of the ovary as it prepares to be released. This may be helpful for visual learners. This shows the ovarian cycle divided into the follicular and luteal phases, illustrates the development of the follicle up to ovulation and its subsequent transformation into the corpus luteum once the egg has been released from it. The rise and fall of these hormones are also depicted here, and you may want to return to this image after the hormones are discussed. This is an illustration of an ovary, and it demonstrates the development of the egg-containing follicle. You can start with these primordial follicles, and these tiny structures are essentially the starting point for egg development within the ovaries. Each primordial follicle consists of an immature egg surrounded by a layer of supporting cells. As the female matures, some of these primordial follicles will develop further into primary follicles. Each primary follicle consists of an immature egg cell, also known as an oocyte, and then it's surrounded by a layer of cells. These cells provide support and nourishment to the developing egg cell. As a female reaches reproductive age, and typically during puberty, primary follicles begin to mature in a process called folliculogenesis. During this process, the primary follicle develops into a secondary follicle and eventually into a mature Graafian follicle. The primary follicle also plays a critical role in the production of estrogen. There is something called the zona pellucida, and it is a specialized extracellular matrix that surrounds the oocyte within the female follicle. This translucent membrane plays a crucial role in fertilization by facilitating the binding of sperm to the oocyte. It's made of various glycoproteins and acts as a barrier, allowing only one sperm to penetrate and fuse with the egg during fertilization. Additionally, the zona pellucida helps protect the developing zygote as it travels down the fallopian tube towards the uterus. This slide provides a summary of folliculogenesis from primordial follicle through ovulation, and then the formation of the corpus luteum and its degeneration into the corpus albicans. Ovulation occurs when the mature egg is released from the ovary. This process typically occurs around the middle of a woman's menstrual cycle. The ovary releases the egg due to a surge in LH and FSH from the pituitary gland. So you can look at the table again provided earlier in the packet. The oocyte is released into the abdominal cavity to be swept up by the undulating fimbriae, and then taken up into the infundibulum, passing through the ampulla and the isthmus before entering the space of the uterus. Implantation occurs if the egg has been fertilized, otherwise it is shed with the endometrial lining during menstruation. During the post-ovulatory phase of the ovarian cycle, also known as the luteal phase, the ovary undergoes several important changes. Following ovulation, the ruptured follicle transforms into a structure called the corpus luteum, which secretes progesterone. This hormone prepares the uterus for possible implantation of a fertilized egg. It's responsible for thickening the endometrial lining to support pregnancy. If fertilization does not occur, the corpus luteum will degenerate, leading to a decrease in progesterone levels. This drop triggers the shedding of the uterine lining, resulting in menstruation and marking the start of a new cycle. Okay, so let's move on to the second structure that needs to be understood to fully appreciate the menstrual cycle, the uterus. I have indicated in a few previous slides what is occurring here already. The uterine cycle includes the proliferative and secretory phases. During the proliferative phase, which typically occurs in the first half of the menstrual cycle, the primary goal is to prepare the uterus for potential pregnancy. This phase is characterized by the thickening of the endometrium, which is the inner lining of the uterus, and the hormone responsible is estrogen. The endometrium becomes rich in blood vessels and nutrients, and it creates a welcoming environment for a fertilized egg to implant. Following the proliferative phase, the secretory phase takes place in the second half of the menstrual cycle. This phase is primarily influenced by the hormone progesterone, which is released from the empty follicle after ovulation. During the secretory phase, the endometrium continues to thicken and the uterine glands begin to produce substances that further support a potential embryo. If fertilization does not occur, hormone levels drop, signaling the shedding of the endometrial lining, resulting in menstruation. This marks the end of one cycle and the beginning of a new proliferative phase. If fertilization does not occur, the hormone levels drop, signaling the shedding of the endometrial lining and, resulting in menstruation. This marks the end of one cycle. And the fluids discharged during menstruation includes blood, serous fluid, and endometrial tissue. The average loss of blood amounts to 40 milliliters, and also shed is 35 milliliters of serous fluid. Just as an illustration or an illustrative table was provided for the ovarian cycle, here's one for the uterine cycle. The image follows the events occurring in the uterus. And this shows the overlap of the ovarian and uterine cycles and indicates the pattern of hormonal releases during the entire cycle. Okay, and the last table shows the list of hormones required for function in the reproductive system, starting at the top with this hierarchy is the hypothalamus.